Hello. Hello everyone. Am I audible? Hello. Am I audible? Okay. Let's assume that I am audible and let's start. Okay. So let's minimize this window and so let's start. Okay. Okay, let's check if it is okay to okay. Let's start today's webinar, which is class 11, and the topic of today's webinar is projectile motion. Today, in this free webinar, I am going to discuss the topic of projectile motion, and if anyone is interested, then they can enroll in my course, and I am going to give a coupon code at the end of the webinar. Now, without further ado, let's take pen and paper and get started. So the topic that will be discussed today is projectile motion. Now, whenever we throw an object at an angle theta with the ground, then that type of motion is called projectile motion. Now, when we draw the diagram for projectile motion, we get x-axis, y-axis, and the object is thrown at an angle theta. Let us assume that the object is thrown at u velocity. Then the horizontal component or the component at x-axis is called u cos theta, and the vertical component or the component at the direction of y-axis is called u sin theta. These two are the two components of the velocity. Now the horizontal component is required to find the range of the projectile motion, and the vertical component is required to find the maximum height of the projectile motion. Let's call this maximum height h. Now whenever we throw an projectile, the horizontal component remains constant throughout the projectile motion. However, the vertical component decreases and reaches 0 at the maximum height. Then it increases in the negative direction. So, throughout the projectile motion, the horizontal component remains constant and the vertical component changes. Now, let's talk about what happens with the horizontal motion. Now, as we see from the diagram, the horizontal component of the velocity, that is u cos theta, remains constant. So, velocity in horizontal direction remains constant. If the velocity component in the horizontal direction remains constant, then that means there is no acceleration in the horizontal direction. So we can say that horizontal component of the acceleration, which is denoted by a suffix x, is 0. We can also say that this is x component of the acceleration. Now, from equation of motion, we know that, let's write down the equation of motion first. We know from equation of motion that v equal to u plus at. This is one equation of motion. Then we know s equal to ut plus half at square. This is another. And the last one is v square equal to u square plus 2as. This is another equation of motion. Now, we can see that the acceleration for the horizontal direction is 0. So from equation of motion, we can write vx equal to ux plus at axt. So from this we can write vx equal to u cos theta, as the ax is 0. Let's call this equation number 1. Again, we can see that sx equal to uxt plus half axt square. We take the x component of all the equation of motion, that the x component of distance, which is denoted by s suffix x, and the x component of the velocity, which is denoted by u suffix x, and the x component of the acceleration, which is denoted by a suffix x. Then for horizontal motion, a suffix x or acceleration is 0, so we can get ux, the value of ux, that x component of the velocity is u cos theta. So we can say u cos theta multiplied by t, and as acceleration is 0, so there is plus 0 and this becomes the equation number 2. Now let's talk about vertical motion. What happens in the vertical direction is, we know from equation of motion that v equal to u minus gt. Here we see that equation of motion is v equal to u plus at, but whenever we are throwing an object in the upward direction, the acceleration or the gravitational acceleration opposes the motion that is going in the upward direction, hence there is a negative sign. And as we know that the acceleration due to gravity is denoted by g, so this equation becomes vy equal to u suffix y minus gt. Again, when we are looking at vertical motion, the component that we need is the vertical component or y component of the velocity, and it is u sin theta. So we get vy equal to y component of u is u sin theta minus gt. Let's take this equation as equation number 3. Again, for another equation of motion, we get the same thing, that s equal to uyt minus, because the motion is opposed by the gravitational acceleration, so minus half gt square. Again, the y component of u is u sin theta multiplied by t minus half gt square. So this is equation number 4. Also we get here the third equation of motion, that is vy square equal to uy square minus 2g s suffix y. Okay, now here this s suffix y, that means the distance in y direction. This is actually the height of the projectile motion, and the s suffix x, which is distance in x direction, is actually the range of the projectile motion. Again, if at any time we need to find out the resultant velocity, then we know from the vector that how to find a resultant is taking square root of the component, that is root under vx square plus vy square. If we try to find out the resultant velocity, we can say that the x component square plus y component square and square root of that is the resultant velocity. Now if we try to find out the angle between, or the angle the resultant makes with the x component, that is tan theta Vy by Vx. So these two formula we know them from the vector. Again, if we try to find out equation of trajectory for the projectile motion, we have to go to equation number 2. So from equation number 2 we can see that s suffix x equal to u cos theta multiplied by t. So we can write it as s suffix x by u cos theta equal to t. So we can write it as from 2 t equal to s suffix x by u cos theta. Again, from equation number 4 we can see that sy equal to u sin theta t minus half gt square. So we take the value of t and put the value of t in this equation number 4. So what happens? From 4 we get s suffix y equal to u sin theta multiplied by s suffix x u cos theta minus half g into s suffix x by u cos theta. Okay, again s suffix y equal to this u gets cut and this becomes tan theta sin theta by cos theta, that becomes tan theta multiplied by s suffix x minus g. Okay, this will be whole square. Okay, so minus g by 2u square cos square theta and multiplied by s suffix x square. So if we take the sy as y and the sx as x, then we get this, and let's write the tan theta as a and minus g by 2u square cos square theta as b. So this equation of trajectory comes out in the form of y equal to ax plus bx square, where the a is tan theta and b is minus g by 2u square cos square theta. The next thing that we need to determine is the maximum height reached for a projectile motion. For this equation, let's go in the vertical motion. In vertical motion, from equation number 4 we can see that s suffix y, which is actually the height, equal to u sin theta minus half gt square, and from equation number 3 we can see that v suffix y, which is the velocity at that particular height, equal to u sin theta minus gt. Now from this equation number 3 we can say that what is the velocity at maximum height. The velocity at maximum height is actually 0. So from equation number 3 we can write 0 equal to u sin theta minus gt. So we can write u sin theta minus gt equal to 0. That becomes t equal to u sin theta by g. So let's take this equation as equation number 5. Again, from equation number 4, we put the value of t in the equation number 4. So what we get? We get h equal to u sin theta multiplied by time, that is u sin theta by g minus half g t square. T, the value of t is u sin theta by g whole square. Again, if we multiply this, we get u square sin square theta by g minus u square sin square theta by 2g. So if we take u square sin square theta by g common from both sides, we get 1 minus half, which gives us half. So this becomes u square sin square theta by 2g. Let's take this as equation number 6. Now let's try to find out the time of flight. What is time of flight? The time taken to reach, to complete the whole projectile motion. That means the time taken to reach from here to all the way to here. That is the time of flight. We already determined the time taken to reach maximum height, that is from here to here, is t equal to u sin theta by g. We already derived that value in equation number 5. So now let's try to find out what is the total time taken for maximum height. Again, we are trying to find out the total time taken for the whole projectile motion. From equation number 4, we can say that Sy equal to u sin theta t minus half gt square. Now Sy is actually the height of the projectile motion. So if we take a look at the diagram, whenever the projectile motion starts, then the height of the object becomes 0, or the height of the projectile motion is 0. And whenever the projectile motion completes the whole motion, then also the height of the projectile motion becomes 0. So we take the height of the projectile motion as 0. So we can write from 4 that Sy, that is 0, equal to u sin theta multiplied by t minus half gt square. Now that becomes, let's take t common and we get u sin theta minus half gt square. Sorry, if we take t common, we get u sin theta minus half gt equal to 0. We get either t equal to 0 or u sin theta minus half gt equal to 0. That gives us u sin theta equal to half gt, that gives us t 2u sin theta by g. Now from the diagram we know that the height becomes 0 at two position, that is at the start of the projectile motion and at the end of the projectile motion. So we get two values of time here, that t equal to 0 and t equal to 2u sin theta by g. But at t equal to 0 is actually initial position, or the position at the start, initial position at origin or at point O. So the remaining time that we get from this equation is the time of flight, or the total time taken for the projectile motion. Now let's take a look. Let's take a look. Now from this calculation we get that total time of flight equal to t equal to 2u sin theta by g, and the time taken to reach the maximum height is t equal to u sin theta by g. The time taken to reach the maximum height is t equal to u sin theta by g. So we get this from equation number 5. So we can see that the time taken to reach the maximum height is actually half of the time taken of the whole projectile motion. That means the time of flight is actually 2 times the time to reach the maximum height. So from this we can say that the time taken to reach the maximum height and the time taken to reach from maximum height to ground is actually the same. So from this we can write that the time of ascent is actually equal to the time of descent. Again, if we try to find out the range of the projectile motion, for range we can say that we take the horizontal motion and the horizontal component of the velocity into account, and we know that u cos theta will work for the u cos theta of the horizontal component will work for range. So we know from equation number 2 that the range, or s suffix x, or distance in the x direction, is actually u suffix xt plus half axt square, and we know the acceleration in the horizontal direction is 0, so we get sx equal to uxt, and we know that the x component of the is velocity, x component of the velocity is u cos theta, and t is the total time of flight. And we have already determined what will be the total time of flight. So from here we can calculate the range. So the range, we write the s suffix x by r, and we get that equal to ux multiplied by t, where ux is the x component and t is the 2u sin theta by g. It becomes u square 2 sin theta cos theta by g. We know that 2 sin theta cos theta can be written as sin 2 theta by g. Let's take this equation as equation number 7. Again, to find the maximum range, for a given u, we have to take the value of sine maximum. The value of sine must be maximum, and we know the value of sine has a range of -1 to +1. So we can see that this value will only be maximum when the value of sine portion is 1. Then we get, for a given velocity u, r is maximum, that is range is maximum, when the value of sine will be maximum. That means the sine portion will have the value of 1. Now when the value of sine becomes 1, when the sine is 90 degree, again we get that 2 theta equal to 90 degree and theta equal to 45 degree. So from this we can say that the range will be maximum when the value or the angle at which the projectile is thrown is 45 degree. So when we throw it at a angle of 45 degree, the range becomes if we take the value of sine as 1, u square by g. So this is the maximum range for the value of 45 degree. So this is how we solve the projectile motion, and this is the formulas for projectile motion. Now we have to do some problems to actually understand or actually master these formulas, so then we can be proficient in it. Now let's see if there is some question. Okay, so there is no question right now. Okay, so now in my course, let's talk about my course that is going to start. So in my course for class 11, I am going to teach you in live class about all chapters of class 11. Obviously the chapters are, you already know that what is the syllabus, but I am just repeating for. So obviously the chapters are physical world and measurement, kinematics, laws of motion, work, energy and power, motion of system of particles and rigid body, gravitation, properties of earth matter, thermodynamics, behavior of perfect gas and kinetic theory of gases, oscillations and waves. Now all chapters will have more so that you can evaluate yourself. I will also solve any doubt regarding any chapter. For this, a private group will be created. In this course, you will get one class every week, and the class will be of 2 hours. The class will start from Wednesday 7 p.m. next week. Now I am releasing my program class 11 physics course with a ton of bonuses. and I am going to take on a handful of few students. The course will be charged at a rate of 1000 rupees per month, but not everyone likes monthly payment where money gets deducted automatically. So I will divide the course on the basis of each month so that you can only continue the course if you truly want. Now I will tell you the discount code which will give you 100 rupees or 10% discount, making the course fee 900 rupees per month. The coupon code is webinar10. Let's write everything in capital, and the coupon code is webinar10. Okay, I have also wrote it down for the sake of convenience. Now, if you are someone interested in this course, please click the link below and put your name and email. Stay tuned for the next video. Okay, let's see if we have any no comment. Okay, so we can just end this stream.